Hey, welcome to BrewskiTech. So today we're going to be working on another fermenter project. This is going to serve the same purpose, but instead of using ice bottles and a fan to chill the fermenter, we're going to use a real chest freezer, like this one. It could also work with a refrigerator. Now, the difference with this one is, hopefully, it's going to be quicker and easier to build than the last fermenter. The reasons for that are really two things. The first is we're going to build it on a breadboard, so no soldering or very little soldering is required. The second thing is for the AC control, or for turning on and off the entire freezer, we're going to use this pre-built unit to power the freezer when we need to. Now, I'm not going to go into as much detail as I did with the previous fermenter project, so definitely refer to those videos as kind of a reference, because we're going to be building on that in a lot of ways. If you're curious or there's not enough detail in this video, definitely check out that other video series where we go into a lot more detail, especially as it concerns Home Assistant and ESPHome. The reason I'm doing this, I'm trying to do it quickly for my own use. The reason is because the previous fermenter works great, except it has limits to how much it can cool your beer while it's fermenting. So probably something like 20 degrees below ambient. This one, on the other hand, can go all the way down and actually freeze your beer, colder than you would want. It's better in the case that I care about right now, which is I want to brew a lager in the middle of summer. And my basement is just a little bit too warm for the other fermenter to really work. This is going to work much better for lagers and things that need to be held colder and for longer periods of time. Thanks for tuning in for this video, and let's get started. So let's quickly go through the parts that we'll need for this project. So first up is we're going to be using a breadboard to put these parts together on. We could solder this together, but it will be faster to do the breadboard method, and this is so simple that the breadboard will work just fine. So, small breadboard. Next up is the brain of this contraption. This is a Wemos D1 Mini. This is probably, I don't know, $2 or $3 each for these. They're very inexpensive. This is using an ESP8266 processor on here, which has a Wi-Fi radio built in. This is actually the same chip that's used on the Node MCU that we used in other projects on the site. Really the only difference here is the Wemos D1 Mini has less pins exposed, which is just fine for this project, because we only need 2, maybe 3 pins available, and this has way more than that, as you can see. Next up is a temperature sensor. So this is just a 1-wire waterproof temperature sensor. Doesn't strictly need to be waterproof, but it is kind of nice because this can be kind of in a wet environment. So we'll be using that for sensing the temperature in our chest freezer or refrigerator. And then the very last thing, let's move all that crap out of the way, is this. This is actually the device. This is called an IoT relay from a company called Digital Loggers. This costs, something in the order of $30 to $40 on Amazon. And basically you can kind of see, I guess I should have pulled it out of the box, but you can kind of see on the picture here, you would just wire in some low DC logic level voltage that's going to come from the Wemos D1 Mini, and it will turn on and off the power supplied to these sockets, which is basically what we're going to use to turn the power on and off to our chest freezer or refrigerator to control the temperature. So that's basically the only components that we need, other than a couple of little minor circuit components, which we'll get into as we assemble it. So first up, let's get into the Wemos D1 Mini. I think I'm just going to call this the D1 from now on. So this one that I got did not come with pre-soldered headers, and instead they just supplied basically every type of header you can imagine. This one you can go through the pins, and it actually acts as both a male and a female header. This one is a female header that you can solder on. But for our case, since we're going to plug it into a breadboard, I want to use these male headers. And I'm actually going to use the breadboard itself to align the header pins so that they're all lined up perfectly. So we're actually going to push those into the headers on both sides. So this is great. The breadboard's going to act as basically like a helping hands or a soldering station for me. If I can get this, there we go. So now we can look, that's all, if you can look down the center, you can see they're all lined up and everything looks like 90 degrees, and it's going to kind of hold it in place as I solder, which is perfect. Now, if you've never soldered before and this kind of scares you, I'm not sure, they might sell these Wemos D1 Minis with the headers pre-soldered. That might be what you want to go for. Eventually we're going to have a soldering tutorial on the channel, but at the moment we don't have anything. So hopefully you can you already know how to solder, or you can check out a tutorial online to do this. The good news is soldering headers on is pretty simple, or it's an easier sort of soldering job. So here, let's go ahead and do it. So I've already got my soldering iron hot. I'm going to heat up the joint. I'm going to do one side, and then I'm basically tacking this down. So I'm doing kind of opposite corners. That should be ready to go now. Okay, next up, let's get the power supply set up, the power supply lines. So we are going to be using the power from the Wemos D1 Mini. That will indirectly come from USB. So I've oriented this so that the USB port is on one end of the breadboard here. And then you'll notice that we basically have one connection point for each pen on either side of the Wemos D1 Mini, so which is fine for this. So our first thing we're going to actually connect together on the breadboard is I want to have power rails, both power and ground, on these buses on the outside of the breadboard. So the first thing we're going to do is actually going to mark with a little permanent marker. We're going to mark the buses so that we never mess them up. So we never flop them or flip them. So I'm just going to put a big plus on this one. This is where the positive power supply voltage is going to be. And then I'm just going to put a big minus on the other one. Okay? So now I'm going to grab one of these. I'm going to get some tweezers because my fingers are too big for this. Okay, so I'm going to grab, this is just a little jumper wire kit that I use for breadboards because it's just really handy. I think I talk about that in the breadboard video. That one's a little too long. Let me get a shorter one. Actually, that'll be fine. Okay, so first let's connect the 3.3 volt pin on the Wemos D1 Mini, which is basically this one all the way at this far end. Let's zoom in a little bit. Okay, so we're going to connect there, and then we're going to connect to the bus with this jumper wire. So just push this down. Okay, so now you can see that 3.3 volt pin is connected to the plus, or the positive marked bus. Okay. And then on the other side, there's a pin called G, that's ground. We're going to do the same thing over here with ground. This one is the second pin in from the USB port side. Okay, so that looks like it's connected to the right pins. Okay, so now you can see here the G, or ground line, is connected to our negative bus. Okay, so now we know 3.3 volts is here and ground is here. Let's never mix those up. Okay, so now our Wemos D1 Mini is attached to the breadboard in the right orientation, and we have the power supply rails connected for this breadboard. All right, so our next step is we're going to take our temperature sensor and get it wired into the board. But the first step is, this came with unstripped wires. So first step is we're going to strip these wires. I'm just using an very old pair of wire strippers. So we just want to strip off, what is that, about 1/4 of an inch of the insulation. There you go. And I like to, especially for these little thin, this is stranded wire, you can kind of see that it's more than one little thin wire inside there. That's called stranded. I like to kind of twist these together to protect the strands. So just kind of use a twisting motion with your fingers, and that'll help keep all the little strands together. We could actually solder these, like tin them up, which wouldn't be a terrible idea, but not absolutely necessary. You know, I think I will tin these up since I've already got my soldering iron handy. I'll still twist them, but it just helps to protect these wires and add a little bit of strength and strain relief to these little tiny thin wires, just to tin them up, which just means we're going to heat them up, flow a little solder into the wires. That'll kind of stick those strands together and make it so that they're a little bit tougher. Yeah, let's go ahead and tin these up. Again, this is not absolutely necessary, but it's probably a good practice, good thing to do. Okay, so those are tinned up a little bit. Maybe not perfectly, but better than they were. Okay, so we're going to call that good. Now these little thin wires, even once we've tinned them up, they won't go directly into the breadboard. They're just too small, and kind of just the gauge is too small. So what we're going to do instead is, this is a 3-position screw terminal. So this will plug directly into the breadboard. At least I hope so. It won't turn me into a liar. So we're going to plug that right in. Okay, there we go. That's in. And then we're probably going to wait till we actually install this and test it and everything to actually plug these wires in. But basically we're going to wire up everything to the screw terminal as if it was directly connected to the temperature sensor wires, which it will be. Now the way we're going to wire this is, we're going to have the red one is power, so we're going to hook up the 3.3 volts to that one. The black one is ground, so we're going to hook that up to the ground bus. And then the yellow wire is actually the data line, so that one's going to go to one of the pins on the D1, and so that it can communicate with the temp sensor. This top one will be power, this will be ground, and then the middle one will be the one that we wire up to the Wemos D1. Okay, so let's set aside our temp sensor for the moment. There we go. This one will work. So we'll wire that up to our power bus. Okay. There you can see, that one is basically the line of the breadboard that lines up with the middle, which is basically where the terminal is plugged in, is plugged into the power bus. Okay, now let's get a slightly shorter wire. Let's go ahead and hook that up to the bottom line. So it's going to go here, and then we want to just bring that around and plug it into the ground bus. let's see, since this is going to be okay, so now we've hooked in the bottom screw terminal is wired across to the ground bus over here. Okay. Now, the last one is, let me see, let's do... And let's see, which pin should we hook this up into? Let's do D1 for this. If we need to change it later, it's very easy to change. One of the advantages of using a breadboard, but yes. Okay, so now here you can see that middle terminal I've got wired up to the pin that's marked D1. Or at least I think it is. Those are tiny little numbers, but yeah, D1. Basically the setup, oh, I forgot one thing. So we will also need signal line to be pulled up to 3.3 volts. So we're going to use this 4.7 kilo ohm resistor, and we want to connect it between the signal line, which we have one more hole open for that, and the power line, which we could just do the one that's right next to it, but there's a lot of wires running through there, so let's just plug it into the power bus. Okay, so that's something about the one wire bus that these temp sensors use, is they need a pull-up resistor to the power voltage, which in our case is 3.3 volts, so we're going to go ahead and do that. Okay, now that should be everything we need for the temperature sensor. Oh, one more thing. So since I have my marker handy, I'm going to go ahead and mark the screw terminal itself. So I'm going to put a little minus sign on the side that connects to ground, and I'm going to make a little, I don't know if you can see that in the video. Again, I'm not sure if you can see that very well, but I put a little plus sign on there. Again, this is just so that I don't forget when I'm wiring everything up later which side is power and ground. The other thing too, this screw terminal is pretty solid in the breadboard, but they aren't always, and since the screw terminal takes a lot of like abuse or force, you know, as wires are moving around and stuff, since this is going to be a kind of a permanent installation, if you have a hot glue gun, you might want to put a blob of hot glue on either end of the screw terminal just to kind of make it a little more secure. I don't think I'm going to do that for this. I might use hot glue later to secure some of the wires, but anyway, that's an option, again, because this is a permanent installation. We've got our temp sensor wired in, or at least set up to be wired, and then we've got our Wemos D1 plugged in. The last step is to set up the thing that's going to be turning power on and off. So that's this IoT relay thing. This is a big block, but the way that it wires in is these little screw terminals over here. So the way to get to those is you have to kind of, this little green block is, you just kind of got to wiggle it loose. It's meant to plug into this recess here. But the cool part is we can just operate directly on this screw terminal and then plug this in later. Okay, so again, I keep marking everything. I don't like to mix up power and ground because it usually will lead to bad situations. So I'm again going to mark a minus for the ground side and a plus to the positive side, and I got that from the actual little notation on the device itself. So see, minus over here, plus on the other side. Hopefully we will not mess that up. Okay, and then I'm going to grab two of the longest jumper wires. Let's go ahead, pull these big long green ones out. We're going to use these to basically connect up to these screw terminals. So let's pick our pins. Actually, let's do the screw terminal part first. And that one's pretty secure. Okay, so this is the positive wire up here. We're going to now wire this up to the pin on the D1. I'm going to fairly arbitrarily pick pin D5. So that's going to control power. We'll have to remember that for later. Okay, and then the other one we can just hook up to the ground bus, which, just because of the length of these wires, I'm just going to use a free row in the breadboard, and I'm going to do another jumper over to the ground bus. This will just make it so that it'll hook up a little more cleanly later on. So let's see. Let's find a free spot on the ground bus to hook this together. Okay, here we go. Let me show you what I did. So we have a little jumper that goes from the ground bus here over to this free row on the breadboard, and then the minus terminal of the relay device is connected directly to that ground. And that is pretty much it. And then when the time comes, I'm going to leave this disconnected for now because I want to do this when we wire up the temperature sensor and this when we're kind of on our final installation. But we'll just plug it right back in like this, and then the Wemos D1 Mini will be connected to our IoT relay. Okay, so I skipped showing this on the video because it's not that important, but here is the project mounted down to a board so that I can mount it either to the refrigerator or freezer or the wall behind it or whatever. The big point with this, you can do it however you want, but the big thing this is providing is strain relief. So you basically don't want anything pulling on the breadboard, on these little wires. Because it is a breadboard, it can pull the wires out very easily. So you want to have everything secured. So this is screwed down. The breadboard is screwed down to the board, and I used this is a cable staple like an electrician would use to secure the end of the temperature probe. You don't have to use one of these. I just had one on hand, so it was handy. But you can also you could use hot glue and put this cable in a blob of hot glue, and that would work too. But the big point is to secure it. Do it however makes sense to you. I just used scrap wood and whatever I had on hand to do it. I would suggest doing the same thing. Oh, I also put these big magnets on the back of the board so that I can stick this to the metal sides of my chest freezer. I honestly don't know if this will work very well, so I might end up having to just like screw it into the wall next to the chest freezer, but we'll see. I'll try the magnet method. So here is the temperature controller mounted to the side of my chest freezer. I just used magnets that are hot glued to the back of the board here. It's maybe not the best mounting method, but it allowed me to stick this to the side of the chest freezer without having to drill any holes and maybe damage the freezer. I did find that the magnets hold it on pretty well, but the sides of this are just sheet metal, and they're so slick that the thing would actually slide down. So I actually put some double-sided tape underneath the magnets, not really to hold it to the side, but just to kind of give the magnets a little bit of friction so that this board wouldn't slide down the side. I'm not really in love with how I mounted this on here, but it does seem to be working, so I'm not sure I really recommend that. So just mount this however you want, maybe even to the wall next to the chest freezer. Other than that, really all you have to do is plug in the refrigerator or chest freezer into the one of the sockets that's labeled normally off, and that's pretty much it. You can turn power on and off to the entire kind of control relay here with this switch. So I can turn that on like that. You can see the little power LED comes on. So if you ever just want to like turn the chest freezer off, regardless of what the the controller is telling it to do, you can just hit this power button and that will kill power to the chest freezer. Now, as far as the temperature sensor, really you just have to put the temperature sensor inside the chest freezer. But I like to attach the sensor to a bottle filled with water, or in this case it's filled with sanitizer. I just have it rubber banded onto the side of the bottle. This is to just stabilize the temperature that it's reading a little bit. If it was just loose in the chest freezer, when the chest freezer turned on, it would get cold very quickly because it's just a little tiny temp sensor. But if you attach it to something with a bit of thermal mass, like a bottle of water, then that helps kind of stabilize the temperature change. You could also just tape that temperature probe to the side of your fermenter or a keg or whatever you're keeping cold in here, and that would also serve to stabilize the temperature reading. So I definitely recommend doing something like that with the temperature sensor. Okay, so now that we have the hardware built, let's go ahead and configure it so to make it actually do something. So, little disclaimer on this next part. We're going to be using ESPHome to do this, as we do on many things on this channel. In this video, I'm not really going to focus on an introduction to what ESPHome does, how YAML configuration files, which we're going to look at here in a moment, work, or how you compile and download that YAML file to your actual hardware. I did a pretty in-depth take on that in a previous video, which a link to that should be on the screen now. So I'm going to skip over all of that, but if you'd like to see any of that, I highly encourage you to watch that video. In this video, we're going to take a look at the YAML file, but I'm just going to focus on the differences between that I made, or the changes I made to this YAML file versus the one from the previous project. So let's go ahead and dig into that now. So first, I'm calling this device Fermenter 2 because I'm super original. Go ahead and I'm going to hit the edit button here, and we're going to pull up the YAML file. So this basically tells all about the hardware and how it should be set up. So as before, or as in that previous project, we're going to use this climate object as the thermostat for the fermenter. Again, see that previous video for more in-depth kind of coverage on how that all works. But in this one, I'm going to focus on a few elements that I added, which are different from the previous video. Now, all of these things I'm going to talk about here are all set up so that we're going to prevent short cycling for our refrigerator or freezer that's hooked up to this thermostat. And we want to do that because the compressor that is in those freezers, they don't like to be what's called short cycled. So you want to turn them on or turn them off for probably at least 5 to 10 minutes each time. So if you're turning them on and off more quickly than that, it actually can basically hurt the compressor. It can make the compressor so it won't last as long. So we want to avoid that if at all possible. So these values that we're going to talk about here shortly are all configured to avoid short cycling our freezer or refrigerator. I'm going to leave a link in the description. All of these items are talked about in more detail in the ESPHome documentation. They have really good documentation in ESPHome. So I'll leave a link to that if you want to read more about these and set your own values here. But for now, I'm just going to real briefly talk through these. So let me zoom in a little bit so we can see this a little more clearly. Okay, cool. Okay, so this first one is startup delay. So this basically, what it does is it says, hey, if your controller gets power cycled, like let's say the power goes out or you pull the plug from the wall or something like that, when you start it back up, it's still going to obey these delays that we're going to set up here in the following one. So it won't just turn on, when you plug and replug it into the wall. It'll obey these delays, which is good. So that's going to prevent startup being a source of short cycling. Okay, so the next thing is these cool deadbands and overruns. So this basically controls, this is about a little over 1 degree Fahrenheit. These are in Celsius, but basically it says like you have to get above your set temperature by this amount before it will actually start or turn on the compressor. So this, again, it was about 1 degree Fahrenheit roughly. And so basically say you had your compressor set to, or sorry, your set point set to 50 degrees. It will wait until the temperature rises to that set point plus the deadband here, 0.5 Celsius. So it would actually not turn on the compressor to start cooling things down until you got to 51 degrees Fahrenheit, for instance. So that's what basically what these parameters are doing. The next two here, min cooling off time and min cooling run time, is basically sets a minimum amount of time that the compressor will be turned off or turned on when you're cooling. Okay, so this is 300 seconds or 5 minutes. So basically it'll say that regardless of what the temperature is inside your freezer or fermenter, it will basically leave the compressor off for at least 5 minutes. And likewise, when it's running, when the compressor is turned on, it will leave it running for at least 5 minutes. So basically putting those two things together means your minimum cycle time for the compressor or for the freezer will be 10 minutes. Again, this is preventing that short cycling. So you can change these numbers up or down based on your needs, but these are the values that I'm using. Let's see, next up is this minimum idle time. So this is just kind of another one that basically when you're in idle mode, you have to be at least 30 seconds in idle mode. So when you're not in cooling or in cooling mode. So all of these together should hopefully prevent short cycling your compressor or your freezer and shortening its life. This YAML file will be available in links that I provide in the description, so you can copy and paste it into yours and modify it as much as you want. And also, if you want more information about learning about ESPHome, how to compile and download this YAML file, check out that link that is on the screen now. One other thing I'd like to note with this project is the thermostat that is built into the chest freezer, which is usually controlled by some kind of dial or something near the bottom of the freezer. In a refrigerator, it might be inside the refrigerator. We want to basically make it so that thermostat never controls the refrigerator or freezer. And the way to do that is without having to go in and rewire the freezer. We can just turn this up to its maximum setting or the coldest temperature for the thermostat. So that will ensure that really this thermostat just never comes into play. It never controls the power to the freezer or refrigerator. And then our smarter thermostat that we have built here will do all of the temperature control. So just make sure that this is turned up to basically its maximum or coldest setting. So after you've done all that work and uploaded your YAML configuration to the device, you should see a screen kind of like this. And this is basically what will allow you to control your brand new thermostat. So right now it's in the off state, but I can turn it on just by clicking on the little button that looks like a snowflake. And now you can see it's cooling, and I can adjust the temperature. And that's pretty much it. It will do its job valiantly. Well, thanks for watching, and if you enjoy this kind of content, hit the subscribe button so you can get a notification when we release new projects.